Yes, Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here. I just want to go to the topic quickly. And this topic is differentiation of inverse trigonometric function. Okay. So before that, we have done the normal trigonometric ratios. Now, first sine inverse of x. Its derivative is 1 over 1 minus x square. This is the simplest equation in which only the angle is being explained here. Okay, angle. In the other one, I will explain that if angle will be any one, so keep in mind that derivative of the angle must be there also. Keep that thing in the mind, that derivative of that specific angle should be there, because any angle is changed, so you must know that derivative of the angle is a must to do step here. Okay. Now, derivative of cos inverse of x. Exactly the same but with the minus sign. Okay. As I told you that sine positive, cos negative. Tangent positive, cosecant negative. Cosecant negative, secant positive, cotangent also negative. So here also inverse function, all the ratios starting with C. Cos, cosecant, cotangent. Their simple derivative also start with negative sign, inverse also start with negative sign. So keep a small step in the mind, okay? This simple trick. The same 1 minus x square, okay? Then derivative of tangent inverse. Tangent inverse of x is 1 over 1 plus x square, okay? So derivative of its cotangent inverse will be equals to minus 1 over same, minus 1 over 1 plus x square. Okay. Now, derivative of secant inverse of x is equals to secant inverse of x is 1 over x, but this x should be in the absolute value, means the positive value only you will consider, square root of x square minus 1, and derivative of cosecant inverse of x is equals to same with the minus sign. Minus sign outside. It's okay?
Yes.
So all the derivatives, these also you have to keep in mind. Derivative of the angles must be there all. Okay. Let's start to prove with this one function. A little bit I will prove. Next you can do it easily. Okay. So prove that derivative of sine inverse of angle is equals to 1 over 1 minus x square. This we have to prove. How we can go for this proof? So let's take this one function. This is the function for which we have to find out the derivative. Okay. So you can say let y is sine inverse of x, means this is the function of y and we have to find out dy by dx. Okay. But before doing it, this is the sine inverse of x we know. But before proving this one, we don't know its inverse function. We have to prove, okay? So we will take the function, we will take the help with the normal trigonometric function. If y is equal to sine inverse of x, it means sine inverse coming here, sine of y is equal to x. Now take now differentiate both sides. Derivative with respect to x here and derivative with respect to here over here. Is that okay? What is the derivative of sine? Cos of the angle, and derivative of the angle equals to 1?
Yes.
Okay. We need to find out dy by dx. So can I go down?
Yes.
Yeah? Like this. Now, I want to change this in the other same, means whatever we are changing, I want to go this in the form of x. So what I know about the identities, you have done this identity in the previous classes.
Yes.
Yeah. So cos square of theta is equal to 1 minus sine square of theta.
Yes.
If I want to find out cos in the term of sine, so cos of theta is equal to this one. So hence we can say cos of y is equal to 1 minus sine square of y square root.
Yes.
So we can use in this place.
Yes.
Okay. 1 over 1 minus sine square y square root. So can I replace the value of sine y from here?
Yes.
Okay. So when we replace the value,
X square.
yeah, it will become 1 minus x square and dy by dx. So can I replace the value of y also here?
Yes.
I replace this also and I replace this
Y.
also.
Yes.
Okay, simply. So I replace this value also, I replace this also. So what was the y? Y was?
Sine inverse of x.
Exactly. So it is done.
Okay.
So the proof of the remaining identities exactly in the same way you can do just by the help of the same basic trigonometric identities which you have done in class 9th, I think. Yeah? Can I write that again or you know that?
Which one?
Cos square theta plus
we
sine
know
square
this.
theta equals 1. 1 plus tangent square theta equal to secant square
Secant
theta
square theta.
and
1 minus
uh-huh,
secant square theta minus 1 to 10. The same. Yeah.
these three were used from grade 9th. I think maybe in some of the curriculum before than that also being utilized, but they are being utilized every time. Okay, so all these identities only now you can tell me if any one is still giving you the trouble, I can solve it now. But your inverse functions must be clear. Tell me anyone I can do next. Let me check that if I can solve that.
Secant.
Secant.
Yes.
Okay, so derivative of secant inverse of x is equal to 1 over x and x square minus 1. Yes?
Yes.
This one is the derivative which you have to prove. Proof. What we can do, what will be our first step?
We will let y equals
Let.
secant inverse x.
Let y is equal to secant inverse x.
We will
Now,
shift secant on the
secant,
side.
yeah, secant of y equal to x, then
And then we'll take the derivative.
derivative
We'll take the derivative.
on both sides.
Yes.
Okay, then
We'll change it.
secant derivative is
Secant y and 10.
secant y and tangent y equal to 1.
1. Yes.
Now both of these ratios must be converted in the same form.
Yeah.
Okay, so I told you this one using this one because secant y value is x, so use this also, and for this also change it into the secant one. Secant y, and this one will be converted as secant square y minus 1 square root. I forget one thing. This is the derivative of secant
dy
dy by dx. Yes. So dy by dx equals to 1.
1.
So this is dy by dx. 1 divided by this one secant y and secant square y minus 1. Now replace the values from here. 1 over, I'm writing over here, secant x, x square minus 1. Because we're not writing it in the negative form, so we take its absolute value. I think thank you so much. Allah Hafiz. Next topic I will apply the inverse function in the next video. Okay, Allah Hafiz.